right, so in this video we're going to talk about explicit formulas and writing those as explicit formulas and functions, which means we just have to write it as f of x and then simplify it. And so here we have a sequence. That's it. That's all we're given. It doesn't say which one's the first term, and so we have to assume that this one right here is the first term, all right? And this would be our second term, and so on and so forth, third and fourth term, right? And so first we're going to do, I always need at least a first term, which in this case is 6. And I also need a common difference or common ratio. I'm going to start off with the explicit formula, and then I will simplify to a function, but I'll just show you how you can go straight to a function as well with a sequence. So let's get started. How do you go from 6 to 12, and then from 12 to 24, and 48, and so on and so forth? Well, let's try addition first. Let's see if this is arithmetic. If we add 6, that would get us to 12, but if we add 6 again, that gets us to 18, not 24. So addition is not going to work. Which means this is not arithmetic. Let's try something else. Let's go ahead and try times by 2. 6 times 2 is 12. That times 2 is 24. And then 24 times 2 is 48. And so we know that we have a common ratio here because we are multiplying, and that common ratio is 2. So now we have a geometric sequence. A geometric sequence is a sub n equals a sub 1 times r to the power of n minus 1. And we just replace some of those values here. So a sub n equals our first term, which we said is 6, times the common ratio, which is 2, to the power of n minus 1. And that would be our, number 1 here, our explicit formula. So now I'm going to go ahead and solve this and go and simplify it down to our function notation. And then I'll show you how you can really easily get that without having to do that. All right, so again, we replace the a sub n with f of x. Equals 6 times 2 to the power of x minus 1. And remember, we don't want the minus 1 up there in that exponent, so we need to simplify this. So f of x is going to equal 6 times 2 to the power of x times 2 to the power of negative 1 is how we'll break this exponent out. And then we'll just keep simplifying. F of x equals 6, can't do anything with the 6, can't do anything with 2 to the power of x, but 2 to the power of negative 1 is 1/2. And there are two numbers here that I can multiply, 6 and 1/2. 6 and 1/2, 6 times 1/2, sorry, is 3. And then I have this 2 to the power of x. And this would be simplified, this would be my function notation, okay? But if you notice something here, this is actually in the form, scroll down here. This is in the form of f of x equals a sub 0 times r to the power of x, where this is our initial amount. We still have the same common ratio. The common ratio is still 2, like we saw above, but the initial amount is 3. And basically, I had to do all this work right here in blue to get to that 3 to find the initial amount. We actually could have found that initial amount here by going back to our initial amount term, our 0 term. Because if I can see I'm multiplying by 2 this way, if I would have saw that to go left here, to go down, I would have just had to divide by 2 to get our 0 term, if you will, right? This would be our 0 term. And if I just would have went to that, I could have easily just said, well, my 0 term is 3, and my ratio is 2, and that would have given me right away 3 times 2 to the power of x. So I didn't have to solve. So this is kind of the shortcut. If you know the shortcut, take it. If not, then just simplify and do that work. Okay.
Cool.
You want this one, Mr. Gray?
Sure. Oh, so we have write a function from a table. And again, we have a table, but the thing that really should tip you off right off the bat here is if I look at my term, and it helps like Mr. Nelson said when I put like an A here, an A here, and an A here, I notice that my terms, my sequence is not in order. I am not going in order there. So one of the ways that we've talked about doing that is you can rewrite the table and fill in the blanks. So I have -2 and -1, but I don't have -1, I don't have 0, and I don't have 1, but I do have 2, which is 7, and I do have 3, which is 9. And so what we can do is try to fill in the table. And the way that we usually try to do this is we try to look, do we have any numbers in the sequence that are consecutive? And the answer is yes. Right here I go from 2 to 3, which is increasing, right? And 7 to 9. Well, that looks like it's increasing as well. And how much is it increasing by? It looks like it's increasing by 2. I was going to try addition before I tried multiplication. So plus 2 works. 7 plus 2 is 9. Well, let's see if that works. So if I go all the way, if this is plus 2 each time, if I go plus 2 to here, this would be negative 1 plus 2 would be 1, right? If I said plus 2 from there, that would be 3. If I do plus 2 from there, that would be 5. If I do plus 2 from there, it's 7. This is the correct thing. So we did this, we filled in the blanks here. Now, because I filled in the blanks and I want to write in function notation, I can go straight to the 0 term. Remember, if I wanted, this is an arithmetic because I have a common difference of 2, and I do have a first term. My first term, a sub 1, is 5, but my 0 term is 3. So I have 2 choices here. I can go a sub n equals a sub 1 plus the difference times n minus 1, and then substitute those values in there for an arithmetic equation. Or I can go straight to function notation. If this is linear, because it's a common difference, then it's f of x equals dx plus a sub 0. And this should be in your notes from earlier on in this unit. So I have 2 choices. Here, I can substitute in and say, okay, a sub n equals the first term, which is 5, the difference, which is 2, times n minus 1, and then simplify by doing it and turning it to f of x. So that means I'm turning this to f of x equals 5 plus 2 times x minus 1, because I want a function. And then I have to simplify by doing the distribution property. And so I'm going 2 times x is 2x, and 2 times negative 1 is negative 2. Oh my gosh, now I gotta add like terms, 5 minus 2, and I get f of x equals 2x, because variables come first, and 5 minus 2 is 3. And I have the function. That's a lot of work. If I just could remember this though, all I'd have to do is say, okay, f of x, I know I need the common difference. The common difference was 2x, and my 0 term is 3. And that was just to fill in the blank, and that is a ton less work than that. So my recommendation is to go that route. All right, the next one, Mr. Nelson's going to come popping up here and do his thing. Oh yeah, oh yeah.
Oh
Should
yeah.
we do that?
Yeah, give me the fractions. Fractions don't scare me. Again, for all sequences, arithmetic or geometric, whether you have to write the explicit formula or whether you want to go straight to the function, in this case it's asking me to do both, so I will do both. We need the first term at the very least. Let me write that in green. We need the first term for our explicit formula, and for our function we will need the 0 term. But you can tell here on this table it doesn't give it to me, right? And so I am going to have to expand this table out. It looks like it goes 3, it skips 4, it goes to 5, it goes to 6, and skips 7, 8, and 9. And it also doesn't tell me my second and my first term. Here's the important part though. Do I really care so much about going up here to 10 and filling in the blanks from 6 to 10? Do I need to figure out what the 7th, 8th, 9th, and 10th term is? It'd be helpful only because I want to make sure that my common difference or my common ratio works for all those parts. So this table's going to take a second to fill out, but it's still going to be doable. So I got x's and y's here, and so see here, I need to work all the way back.
Yeah.
I need to work all the way back to 0 term. So I'm going to go ahead and start off with my 0 term. I don't know what my 0 term is yet, so I'm not going to fill in the y. My first term, don't know it. My second term, don't know it, right? But I do know my third term. My third term is 1/2. My fourth term, not given. My fifth term, well, my fifth term is 2, right? And then my sixth term is 4. And I could stop here. I really could, because if it works, if my common ratio or difference works for all these, then chances are it's going to work out to 10. We should continue on though and work out to 10. Just to double check, 7, 8, 9, and I'll fill this out there in a second, and 10. So there we go. There's my ugly table. And my sixth term is 4. My 10th term is 64. All right, that's a big table to fill out to double check. And just like Mr. Craig said, if you have 2 terms that are right next to each other already, 5 and 6, we're going to go ahead and start there. And because I already know what it is, but if I go at +2 here and I try to check to see if it's arithmetic, because that's always the smarter choice.
Put in 64 and see.
If I add 2 again, I would get 6. Then I would get
8,
8, and then I'd get
10,
10, but I'm
then
not
obviously
gonna,
64.
I'm obviously not going to get to 64 here. So this is not going to add 2 at all here. So let's try something else. Instead of adding 2, another way to get to 4 from 2 is to multiply by 2, right? And so I know this is going to work. 2 times 4 is, 2 times 2 is 4, and 4 times 2
8
is 8, times 2,
16, 32.
16, times 2 is 32, and then 32 times
54.
2 is 64. The question is, how do we work back upward? I can probably go right here and say, well, this is going to be times 2, which would give me 1, but how do we keep on working backwards up to our first term and our initial amount? Well, this way is timesing by 2, which means going the other way is going to be
The opposite.
dividing by 2, right? Or timesing by 1/2, if you will. So 1/2 divided by 2 would get us to
1/4.
1/4. Divided by 2 would give us 1/8. Divided by 2 would
1/16.
get us to 1/16. So, and you can check that out in the calculator by working your way up. And now we can even double check again by doing times 2 to see if it works. And it does work. And you should check all of them just to make sure that you have a common difference or a common ratio that works for all of your table. And so because this is multiply, we have a common ratio. I'll write that right here. That common ratio is 2. Our first term, you can see right here, is 1/8. And our initial amount, which is a sub 0, is right here, and that's 1/16.
Let's go with the second one.
Well, I've got to do both.
Ah.
So write the explicit formula. Remember that the explicit formula, which I'll do here in green, for a geometric sequence, because it's common ratio, is a sub n equals a sub 1 times r to the power of n minus 1. And we can just substitute those in. So a sub n equals our first term, which is 1/8 times your common ratio,
That's 2.
which is 2 to the power of n minus 1. There's your explicit formula. And so that's half of our answer here. Now we need to write the function. And this is why the shortcut's so nice. We can just say, well, the function for a geometric sequence would be a sub 0, initial amount, times r to the power of x. And so just replace. What was our initial amount?
That was 1/16.
1/16, or 1/16, times r, which is r, 2, and to the power of x.
I like that better.
And I'm going to skip all the work, but you could also solve this, and you'd get the same thing here.
It's scary.
It's scary. Very scary. Not really, though. This one looks fun. Come on, Mr. Craig.
Again, we're looking at a situation where we have a table, and that table, I'm going to make this table smaller because I need more room. We have this table that just doesn't have, the sequence isn't in order. There's jumps and skips. So again, we're going to do that whole fill out the table and fill the blanks. Now, some people might say, well, what if the table skipped crazy amounts? This is not always viable. Sometimes you have to do other things. But for what we're doing in this class, this will work pretty much on everything we give you. So again, I start off with the stuff I do know. I do know -3. I don't know -2. I do know a -1. I don't know 0 or 1 or 2. I do know the third term, and I do know the fourth term. And then I'm going to go ahead and line those all up and say, -3, I got 16. At -1, I got 10. At 3, I got -2. And at 4, I got -5. And again, I'm usually looking for where I have things that are in order, in sequential order. It goes 3 to 4. Cool. And again, I look over here and I say, okay, well then what can I do here? Well, it looks like it's getting smaller, and that makes sense because we started at 16 way over here, and we got all the way down to -5. So we're definitely decreasing. And because we're not decreasing, we got to 16, we only got down to -5 4 terms later. I'm guessing it's not exponential. So I'm going to think that it's probably a common difference. Let's see. -2 minus 3 gives me -5. Now let's see if that works. I'm going to go all the way up to the top and see if that'll get me to the 10. So if I take this and I minus 3, I got 13. And if I minus 3, that gives me 10. So I think I got it right. Do you see how I did that? Now, if that didn't work, then I'd go back to the drawing board. But it did work, so I'm going to keep going and see if I get back. Because sometimes, what if it's not a function? What if it's not linear? I minus 3, I get 7. I minus 3, I get 4. I minus 3, I get 1. I minus 3, I get -2. Guess what? That's linear. My difference is minus 3. Now, to write the explicit formula, I need the first term. So I go over here and say my first term is right here. That's a sub 1, and that's going to be 4. So my first term is 4. And for the function, I need the 0 term. And a sub 0 is 7. So my 0 term is 7. The formula for the explicit formula for arithmetic sequences is a sub n equals a sub 1, which is the first term, plus the difference times n minus 1. And so all I have to do now that I've found this information is substitute it in. A sub n equals my first term, which is 4, plus a negative 3. I'm not going to write plus a negative 3. I'm just going to write minus 3 times n minus 1. That is the arithmetic sequence. Now, the function sequence should be, from your notes, f of x equals difference times x plus a sub 0. And so if I do it that way, that's really quick because I'm just going f of x. My difference is minus 3, x, and my 0 term is 7, so it's plus 7. And again, if you have a hard time remembering this, you can get it from here just by going f of x. It's just a lot more work. Memorization, if that's your Achilles heel, then you're going to have to do it this way. I distribute. That's going to give me negative 3x. Negative times a negative is positive 3. Oh, I forgot my 4 right there. F of x. And then I have to add my like terms. 4 plus 3 is 7, so I'm going to get f of x equals negative 3x plus 7. The exact same answer, but one took a bunch of steps, the other one I just had to find the two things and I'm done. All right, hope that helps. Good luck.